So I discussed about the form of wave equation and possible forms for wave functions. ఏంటంటే wave equation must be first order time derivative and second order space derivative. This is one thing, and the form of solution is exponential, imaginary. Okay. So these are allowed, and we will come back to real world by considering linear superposition. That is one possibility. Another is the probability is obtained by modulus square of the wave function. Now, so what are the properties of this wave function? So our aim is to get the entire information about the system just from the wave function, initial condition of the wave function. So that is a primary condition. So we must know when psi carries entire information. We don't need to depend on any other things, especially related to time. Second one, modulus psi square, and psi star psi, complex conjugate of the wave function multiplied by itself, gives you the probability density and then probability per unit volume. So it gives the probability per unit volume of the system. So when you apply the total probability condition, so if you integrate this over the entire volume, must be 1. So psi square gives you the probability per unit volume. So psi square integrated over entire volume gives you 1. So because the system, as long as the system exists in a particular volume, its probability of observation must be 1 in the entire volume. Entire space లో ఏదో ఒక ప్లేస్ లో ఆ సిస్టమ్ అనేది ఎగ్జిస్ట్ అవుతుంది. ఇఫ్ ఎట్ ఆల్ ఇఫ్ ఇట్ ఎగ్జిస్ట్ అవ్వకపోతే దట్ బికమ్స్ 0. So next one, psi must be finite, continuous, single value up to its first value. సో ఫైనైట్ కంటిన్యూస్ సింగిల్ వాల్యూడ్ అనేది చూద్దాము. అండ్ కంటిన్యూస్ అప్ టు ఫస్ట్ డెరివేటివ్ ఇన్ స్పేస్. సో స్పేస్ డెరివేటివ్లో అంటే స్పేస్ పార్ట్ ఆఫ్ ద ఈక్వేషన్ మనం సాల్వ్ చేయాలంటే we require two initial conditions. So this psi must be continuous. Even the first derivative of psi must be continuous in space. So these are the properties of the wave function. So దీనికి కొన్ని ఎగ్జాంపుల్స్ చూద్దాం. psi must be continuous, finite అన్నదానికి ఇన్ఫైనైట్ అన్నదానికి సిచ్యువేషన్ డిఫరెన్స్ ఏమొస్తుంది. సపోజ్ 1/x లాంటి ఫంక్షన్ ఏదో, if psi is 1/x, what happens? It goes to infinity when psi is 0, x is 0. So these kind of functions are not allowed. Psi must be finite. And single value. So some function is like this. So at this point you will have 2-3 values for psi, and this is not. And the final one is psi must be continuous up to its first derivative in space. So continuous అంటే ఏంటంటే కంటిన్యూటీ అనేది మనం కొంచెం డీటెయిల్గా చూడాలి. లిమిట్స్ అండ్ కంటిన్యూటీ అనే వచ్చిన ఎక్కడైనా మ్యాథ్స్ లిమిట్స్ అండ్ కంటిన్యూటీ ఒకసారి చూద్దాం. Okay, so in simple words, psi must be a smooth function of x. There should not be any sharp changes. So sharp changes వస్తే ఏమవుతుంది అనేది చూడాలి. Suppose ఏదో function ఉంది, and if there is another function like this, there are sharp changes. So ఇప్పుడు what is the value of the function at this point? అంటే we get a simple answer, single value. But what about first derivative? So may not be always. నాట్ నెసెసరీ. మాక్సిమం మినిమం అనేది కూడా చూద్దాం. So the slope is 0, it will become 0 if it is flat. So లేకపోతే ఏమవుతుందండి, if you take the first derivative of this function here, dou by dou x ఏమవుతుంది, if you travel from left to right, the function has a rising slope, whereas if you travel from right to left, the function has negative slope. One side it is a rising curve, and on the other side it is a falling curve. So you get two different signs for the slope information. Okay, so that is the issue. These kind of functions, though the function has a finite value, it is not allowed in quantum mechanics. We can't handle such kind of functions because here the slope, space derivative, on left and right has different values. సో లెఫ్ట్ నుంచి వస్తున్న స్లోప్, రైట్ నుంచి వస్తున్న స్లోప్ ఒకటే ఉండటం అంటే ఇట్ ఇంప్లైస్ ద ఫంక్షన్ ఈస్ కంటిన్యూస్, స్మూత్ ఫంక్షన్. So these are the fundamental rules for wave function, because we must derive all properties of the system just from the wave function. That is a primary rule for quantum mechanical systems, because we cannot observe the system or identify the system just from the wave function itself. We have to capture entire information and future of the system, future dynamics of the system. So that's why these are the conditions. So the only exception for this rule means, దీన్ని mathematical ఎట్లా రాస్తారంటే, and dou by dou x one is a plus and another is a minus. The only exception for this rule comes in the case of delta function. So delta function ఏంటంటే, at a particular value the function becomes infinity. if the potential is in the form of delta function, then this condition is not necessary. We will see that in the problems. So in all other cases, psi must be finite, continuous, single value, and continuous up to its first derivative in space. సో ఒకసారి ఆ కంటిన్యూటీ అంటే ఏమిటి, వాట్ ఈస్ ద మ్యాథమెటికల్ మీనింగ్ ఆఫ్ కంటిన్యూటీ ఆఫ్ ఏ ఫంక్షన్ అనేది చూద్దాం.